The impacts from recent wildfires in Colorado are unprecedented. Hundreds of homes have been destroyed, thousands of acres scorched, and worst of all, lives have been lost. As events unfold, electric utilities join those concerned about the speed and direction of wildfires because of power lines that may lie in the fire's path. Another concern is the possibility that the fire may have been started by trees contacting power lines, something not uncommon in the western United States. Xcel Energy's Vegetation Management Group has spent the last several years in preparation for events like these, defining challenges and leveraging new technologies through relationships with innovative business partners.
We've really been so proactive in going after this since we first started seeing the threat, and have really stayed after it very aggressively from that point on.
I travel North America and work with virtually every utility. There are very few companies that truly are leaders in the industry. Xcel Energy is truly one of those leaders.
Power lines are everywhere, crisscrossing neighborhoods, cities, and even mountain ranges. In all of these environments, Xcel Energy's Vegetation Management Group is charged with minimizing the electric service reliability threat that vegetation can pose to the 17,000 miles of electric transmission and 72,000 miles of electric distribution rights-of-way across 8 states.
Vegetation management's been around ever since there's been overhead lines, so the last 100 years or more. And so, in a sense, it hasn't changed a whole lot.
But things began to change when Xcel Energy started to explore the technology known as light detection and ranging, or LiDAR, to assist in vegetation management.
LiDAR is, you can think about it like a laser rangefinder on steroids. Many people are familiar with laser rangefinders. You point a laser rangefinder at an object and it gives you a measurement, a very precise measurement to that object.
When first introduced to LiDAR in 2006, Downie and his team instantly recognized that it could revolutionize vegetation management, particularly in the remote areas of Colorado's Rocky Mountains. Simultaneously, mapping technologies were becoming more digital, incorporating geospatial capabilities such as GPS and other satellite-driven functions. Combined, LiDAR and geospatial technologies would create a powerful new vegetation management tool for Xcel Energy. Inspired by the possibilities, Xcel Energy worked with GeoDigital to explore ways that LiDAR could pinpoint trees and other vegetation that might be too close to Xcel Energy's facilities. By 2007, the two companies were ready to launch a pilot test.
The laser rangefinders are put in the helicopter. This is one of those remarkable things if you sort of step back and realize just how powerful this technology is. We're flying down the line at about 300 feet above ground with a helicopter, with a laser scanner going down the line, throwing 300,000 to 500,000 pulses per second out. And we're capturing all that data back and timing when the light leaves the helicopter until it hits an object. And everything it hits, it gives us an X, a Y, and a Z coordinate of that object.
And really the end result of that pilot demonstrated that the technology could do a fantastic job of accurately determining clearances from vegetation to conductors, and then we could set a threshold distance and say, we want to know about any vegetation that's closer than this distance, and then go out and manage it.
The timing was perfect, because by 2008, Xcel Energy was quickly realizing that its assets were facing a threat in the Colorado Rockies. Poorly managed forests and a growing pine beetle epidemic had left vast tracts of forest either dead or dying. Thousands upon thousands of trees threatened Xcel Energy's lines.
I think you can see across Colorado the lack of management that we've had over the last several decades, the fire suppression policies we had for half a century, and then the warmer and drier weather conditions, especially over the last 10 or 15 years, All those things have come together as a perfect storm that really exacerbate the forest health issues we've had.
Unhealthy forests and hot temperatures led to an unprecedented mountain pine beetle epidemic. No bigger than a grain of rice, the mountain pine beetle has devastated more than 4 million acres of forests in Colorado alone.
The impacts to electric utility infrastructure, really you can boil it down into two categories. One is having a dead tree fall and strike a conductor and cause an outage, obviously, but also spark, maybe catch on fire and be the ignition point for a wildfire. The other category of threat is damage to the infrastructure itself. So no matter where a wildfire might start, having it burn through transmission right away in particular, or distribution for that matter, and damage or destroy facilities is a real concern, especially when we're in terrain like this, and you can only imagine how difficult and challenging it would be to replace structures in terrain like this, and time consuming. And so our next question to Geodigital was, as you're taking this imagery along with the LiDAR, is there a way that you can determine the condition or the health, so to speak, of the trees on and adjacent to our right-of-way?
Using cameras with near-infrared filters, Geodigital proved that it could scan hundreds of miles of lines and pinpoint individual trees that were healthy, declining, or dead. And it could also reveal which of those trees posed a threat to Xcel Energy's assets.
Without LiDAR, we're sending guys out onto the right-of-way, and they're eyeballing, trying to determine what heights are, what clearances are, and trying to identify which trees could possibly be a threat. And obviously, they're going to be very conservative with their estimates. They're going to go after any tree they think has any chance. The advantage to LiDAR is we can pinpoint, precisely identify in a surgical fashion which trees truly are a threat, go after those, and leave the other ones alone, which has saved us millions in terms of managing this hazard tree threat.
LiDAR data points out problem trees and specific areas to be managed, but it is another challenge entirely to get that information into the hands of the teams in the forests, the people who hike in with chainsaws and cut down or mitigate the hazards. Clearion software provided the solution.
The key is giving Xcel tools to manage this program both in the office and in the field. Getting information to the field in a geospatial way, and then getting that information back electronically so that a utility can manage the whole work program.
To understand what it takes to pinpoint a hazard tree in the middle of the forest, and then to tell a ground worker exactly where to find it, imagine layering map on top of map on top of map.
I provide a data set, a background data set of all of our facilities. We put that into Clarion so that we have a mapping system to show the crew where things are. Then the LiDAR flights happen. They process the data for the type of information that we're looking for. We take that data and lay it over the top of those maps. So now we have a way of looking at our facilities along with the LiDAR data, along with maybe the mountain pine beetle data, so that we can get a really good picture when we're in the field of what actually is being impacted and what we need to mitigate at that point.
Then, of course, you have to give that data to the ground crew in a way that's practical and intuitive.
The hardware is a critical piece. It's got to be readable in the sunlight, the bright, mountain sunlight. It needs to be rugged so you can throw it on the seat of the truck and know that it's not going to crash on you. And it needs to be simple to use, simple to navigate.
In 2011, ground crews started using the tablets in the field to identify and remove hazard trees, and the results have been excellent. Approximately 250,000 hazard trees mitigated on both distribution and transmission lines since 2008.
This tablet right here is the key to our entire GIS initiative. Each tablet utilizes GPS and wireless communication technologies and essentially allows field personnel to send near real-time data from the field to a manager who could be miles away. It allows managers to make decisions based on real-time information that can be immediately transferred when acquired from the field. One of the immediately noticeable advantages that the system provided was the ability for crews to know where they were when they were standing on the ground. Invisible boundary lines exist everywhere.
We're on the leading edge. We're really pushing the LiDAR and how it's being used in ways that nobody else, I think, in the country has really looked at it.
Getting the technology all the way down to the front lines with the guys with the boots on the ground and the chainsaws is a big leap, and Xcel is really one of our most innovative customers in that respect.
Encouraged with the results, and with crews furiously working on threats created by the mountain pine beetle and unhealthy forests, the Vegetation Management team started looking at the next opportunity to protect transmission structures from wildfire.
Vegetation management is a really important aspect of the maintenance and operation of the transmission grid. And the reason it's so important is that trees falling into or growing up under lines has been traditionally one of the biggest causes of outages on the transmission grid. And the big worry about outages on the transmission grid is that an outage in one spot can cascade or grow and impact a very large area. And in fact, vegetation issues have been tagged as key causes in very large outages that have occurred in the past, like the Northeast U.S. outage.
In 2010, we decided to form a team, a fire science team. And that team was made up of folks from our transmission engineering group and a consultant of theirs. We hired a fire scientist to join us, had some folks on the geospatial side and people from geodigital that had expertise on the forestry side of things. And so the challenge we threw down to them was we had determined that when it comes to transmission wildfire protection, it all boils down to the structure itself. And we need to protect those structures.
The first unknown that I had was what are the heat thresholds for the infrastructure? How much heat can they stand? We've got the various different structures, which are either H-braces, and they can be wood, steel, or aluminum, and various different steel lattice towers, aluminum lattice towers, wood, and then the conductor, and that's the wire that carries the electricity.
Once the team understood an approximation of how much heat each type of structure could withstand, they had to determine an estimate of how much flammable material could be tolerated near the transmission structures on the forest floor and in the surrounding trees. In a wildfire, those materials would create different levels of heat.
We started talking about how far, what kind of a radius, what kind of a treatment, fuel treatment do we need to do around the base of these structures. And that's dependent, of course, on what kind of material they are, whether they're aluminum, steel, or wood.
Then the team tested LiDAR to see if it could accurately measure the flammable material on the forest floor and the thickness of the forest near our towers.
The idea that we had was let's ask this fire scientist to go and look at about 70 randomly selected structures across the mountain pine beetle epidemic area and have him use traditional methods to quantify the fuel loading on the ground, the surface fuels, as well as calculate crown closure from the forest adjacent to those structures. And then the thought was, in parallel with that, we would have the folks from geodigital try to quantify those same conditions remotely. We had an extremely strong correlation between the results. It was getting close to 90%. So in other words, what our fire scientists said was on the ground in terms of fuel load, tons per acre, and the density of trees adjacent to those structures was almost 90% of the time the same as the results that they were getting from running algorithms across that same LiDAR data set. So that got us pretty excited that, again, we could essentially push a button and calculate the critical factors that we needed to understand in order to attempt to protect transmission facilities from a passing wildfire.
The LiDAR technology just gives a tremendous amount of data that never was available before. And the big thing that it really delivers to us that we didn't have before is the opportunity to have essentially a 3D geospatial model of our facilities and their surroundings. So it shows us exactly how far our lines are from the ground or from any obstruction, how close trees are, how close other issues are, where we might have obstructions of any kind, and just a lot of information that helps us engineer and construct modifications as necessary and also maintain. So a huge amount of information that is helpful both to vegetation management and then also for ongoing engineering and operations of the system.
I'm impressed that Xcel has got the forward-looking vision to say, we really got a problem here and maybe we ought to start doing something about it. And it's setting a trend that I think will be taken up by many other utilities.
Today, the vegetation management team keeps pushing technology to its limits, protecting Xcel Energy's assets and improving public safety.
And the tragedy in Arizona occurred, it really brings home that this is not just some product development thing that if it's not successful, it's no big deal. This actually does matter. It matters that we're able to do a better job of managing managing the risks of fire in these environments that we operate in.
We're looking at issues that haven't even happened yet in an effort to mitigate them before they do. And it's hard to find other utilities that are really acting in that kind of a forward-thinking way.
Xcel Energy takes its responsibility to our community very seriously. This revolution in vegetation management illustrates our persistent drive to use cutting-edge technologies, entrepreneurial partnerships, and hard work to deliver more reliable service and to work toward a safer environment for everyone in the regions that we serve.